Welcome, everyone. Let's get right into it. You are joining us for another deep dive, and today we are looking at something that honestly feels like it is pulled straight out of a science fiction novel.
Yeah, it really
But
does.
the deadlines of the documents sitting in front of me are very, very real. Today is March 4, 2026,
Mm.
and the topic on the table is the rapidly approaching agentic economy.
Right, the agentic economy.
We're talking about a future that these documents argue is practically knocking on the door, where billions of autonomous AI agents are operating, transacting, and negotiating on the internet at machine speed.
It is a massive paradigm shift. And honestly, the stack of source materials we have today is fascinating because it grounds this very abstract concept into concrete nuts and bolts infrastructure. We're looking at internal technical strategy memos from a Wyoming public benefit corporation called IA.XYZ.
Yeah, I have those right here.
We also have outreach drafts that are aimed at some of the absolute heavyweights in the AI space, specifically Dr. Ben Gersel of SingularityNet and the ASI Alliance, as well as the prominent venture capitalist Vinod Khosla.
And it doesn't stop there.
Yeah.
We also have some intensely detailed architectural teardowns of neurosymbolic AGI frameworks, things like OpenCog Hyperon, which we will absolutely be taking apart piece by piece later
Oh,
on.
yeah, we have to. That tech stack is wild.
Rounding out the stack, we have ICANN registry documents, applicant support program filings, and a deep well of data on top-level domains, or TLDs. Our mission for this deep dive is to stress test a very specific, incredibly bold thesis proposed by Michael Core, the founder of IA.XYZ.
And it is a bold thesis.
His thesis essentially argues this: you can't realistically stop AI without turning off the entire internet. Therefore, the only practical path forward is to build safety, governance, identity, and economic alignment directly at the internet substrate layer.
Which is a profound shift in how the industry typically thinks about AI safety. I mean, instead of trying to put guardrails purely inside the software of the AI models themselves, which is what most companies are focused on right now, this thesis suggests we need to build the guardrails into the literal highways they travel on.
Okay, let's unpack this. What we are trying to evaluate today is whether treating AI agents like cars that need a DMV, complete with license plates registration and managed highways at the DNS level, is a visionary world-saving solution or just a logistical pipe dream.
Exactly.
And why should you, the listener, care about any of this? Because right now, as you are listening to this, AI agents are operating in the wild without durable, verifiable IDs. If the internet transitions from a human browsing web where you click links and read pages to a machine transacting web where autonomous programs are negotiating contracts and moving money on your behalf, well, the infrastructure that is being built and argued over today will absolutely dictate your privacy, your safety, and your economic reality tomorrow.
That is exactly the stakes we are dealing with. To understand the gravity of this proposed infrastructure, we first have to fact-check the very premise of this agentic economy. We really need to clarify the transition we are currently undergoing because the vocabulary hasn't quite caught up to the technology.
It really hasn't.
For the past few years, the public's primary interaction with AI has been through simple LLM chatbots. Think of the web interfaces you have probably used. These are fundamentally closed-scope systems. They have what the industry calls a frozen intelligence. They are trained on a massive data set, their weights are locked in, and they just sit there idle, waiting for a human to prompt them. They don't have true agency.
Right.
But the sources we are analyzing describe a rapid shift toward autonomous tool-wielding agents.
And that distinction is everything. A chatbot waits for you to ask it for a recipe. An agent monitors your fridge inventory, realizes you are out of milk, cross-references your dietary preferences, finds the cheapest grocery delivery service, negotiates delivery time based on your calendar, and processes the micropayment, all without you ever typing a word.
Right.
The documents describe these systems as executing multi-step tasks, accessing file systems, operating applications, and even controlling physical robots without constant human supervision.
And the claims surrounding the economic impact of these agents are just staggering. The memos heavily cite a specific prediction to establish their urgency. Let's evaluate the first flagship claim presented in these pitch decks. The claim is that 80% of economically meaningful work will be done by AI by 2030. This prediction is traced directly back to Vinod Khosla in the source materials.
I have to pause there because 80% by 2030, that is just 4 years from the dates on these memos. That sounds almost absurdly high. Are we supposed to take that at face value?
It is crucial to impartially note the sheer magnitude of that claim. The sources aren't necessarily treating it as an absolute certainty, but rather as the foundational urgency for why this specific type of agent infrastructure is needed immediately. If even a fraction of Khosla's prediction holds true, it completely rewrites global economics.
Yeah, it really does.
The logic in the documents is this. If agents are going to perform economically meaningful work, which spans commerce, healthcare data processing, legal discovery, education, and supply chain logistics, they cannot be operating as untraceable ghost programs. They need infrastructure commensurate with their economic weight.
So if we accept Kosel's premise that agents are going to be doing all this work, it begs the question, how much of the internet is actually ready for them? Because looking at the traffic stats in these documents, it is a little terrifying. That leads us to the second major claim, the claim that 51% of internet traffic is currently AI and bots, and soon to be 99.9%.
We have to differentiate the terminology here because not all automated traffic is the same. The internet has always had bots. We have had simple scrapers pulling pricing data pingers, checking if servers are online search engine crawlers, indexing web pages.
By the dumb bots.
Exactly, the dumb bots. But true AI agents are entirely different beasts. An agent capable of multi-step reasoning, context passing across different platforms, and executing economic transactions takes up a fundamentally different kind of network footprint.
The sources highlight a massive gap in how we currently measure and route this traffic, right? We are treating highly complex cognitive cycles from an autonomous agent the exact same way we treat a dumb script pinging a server to see if a website updated.
Exactly. And that lack of differentiation creates a governance nightmare. If network traffic is going to be 99.9% automated, and the network providers can't distinguish between a harmless data scraper and an autonomous financial agent executing thousands of microtrades, the entire system becomes unmanageable.
Which connects directly to the third major claim in the materials. This one centers on a quote from Dario Amodei, the CEO of Anthropic, speaking at Davos. He compared AI to a country of geniuses working in a data center.
It is a great visual.
I love that quote. It perfectly visualizes the sheer concentration of intelligence. But the source material from IA.XYZ points out a critical, almost chilling addendum to Amodei's analogy. The memo states they don't have a country. These AI agents cross borders at light speed. They don't carry passports. They don't have work IDs because they live entirely on the internet. You can't regulate them with traditional geographic border controls like customs agents and import tariffs because their environment is completely borderless.
This is the crux of the geopolitical anxiety woven all through these documents. It brings up the dual futures presented in the IA.XYZ pitch decks. The art direction notes for their outreach materials literally describe a split banner aesthetic to visualize what is at stake.
Oh, the solar punk versus cyberpunk thing.
Yes, exactly. On one side, you have the solar punk vision. Think of a Star Trek utopia, a bright, harmonious, vibrant future where AI and humans are perfectly aligned. In this scenario, the agentic economy is seamlessly integrated, highly verifiable, and actively funding public goods.
And on the other side of that banner, you have the cyberpunk aesthetic. The sources explicitly mention Grand Theft Auto and Blade Runner styles, a dystopia where unverified rogue agents run rampant, causing chaos and an unregulated digital sprawl.
Nobody wants that.
Nobody wants their bank account or their medical records managed by an AI that acts like an NPC from Grand Theft Auto. The core argument Michael Kor is making here is that the difference between that solarpunk utopia and the cyberpunk dystopia isn't just about the AI companies building good AI. It is about having the right internet infrastructure to manage them once they leave the lab.
Precisely. And that brings us to the actual mechanism of management discussed in the documents, which is the domain name system, or DNS. We have to look at the namespace gap and what ICANN, the Internet Corporation for Assigned Names and Numbers, and DNS can actually do in this scenario.
Right.
The problem with our current infrastructure is that DNS was built entirely for human-readable web pages.
Let's do a quick level set for you, the listener, just to make sure we are all on the same page. DNS is basically the phone book of the internet. It was designed so you don't have to remember a random string of numbers, an IP address like 192.168.1.1 every time you want to visit a website. You just type in a name and DNS translates it.
But agents don't care about human-readable web pages. They don't need a nice UI. The sources point out that currently, agent frameworks like one mentioned in the files called OpenClaw are relying on incredibly fragile systems for identity. They use raw IP addresses, which can change dynamically, or they piggyback on centralized ephemeral messaging platforms like Telegram or Discord to maintain an identity state.
Imagine trying to run a global financial system where the major banks only identify each other via Discord usernames. Like, hey, is this actually JP Morgan? Yeah, my username is JP Morgan Real 99. It is completely absurd when you scale it up to billions of machine speed transactions.
It is entirely unsustainable. To evaluate the proposed solution, we need some scope realism about the technology involved. Let's clarify the actors here because the terminology gets dense. You have ICANN, which is the global coordinator of the Internet's naming system. They don't run the Internet, they don't control content, but they manage the root zone, the absolute top of the hierarchy. Then you have registries, which are the organizations that manage specific top-level domains or TLDs. For example, the company VeriSign acts as the registry for .com. And finally, you have registrars, which are the retail storefronts like GoDaddy or Namecheap, where a consumer actually buys a domain.
So what does this all mean for AI agents? Why is Michael Kors so obsessed with this specific layer of the internet? It means that if you want to enforce rules on the internet, DNS is the ultimate globally recognized choke point. The sources highlight that revoking a rogue website at the DNS level doesn't just send a polite takedown notice to a server host, it actually breaks the routing at a fundamental level. If the registry suspends the domain, the entity ceases to be resolvable on the global internet.
Exactly. It is the digital equivalent of stripping someone of their physical address, wiping them off every map, and cutting their phone lines simultaneously. It is a massive lever of power, and this is the immense power that IA.XYZ is trying to harness, but specifically for AI.
Okay, so what is their actual proposal then?
The proposal outlined in the documents is that IA.XYZ is actively pursuing the .ia top-level domain. They are doing this through ICANN's applicant support program with an official organization ID of IA.XL2597.
Their stated goal is to create an internationally legible trust and routing layer specifically for verifiable AI agents. But a question that naturally comes up, and to their credit the sources address this head-on, is why use legacy DNS at all? If we are building the future of AI, why not just use a purely Web3 solution, something like ENS, the Ethereum name service, or purely decentralized identifiers on a blockchain?
It is a vital question, and it is one the blockchain community asks constantly. The analysis in the documents shows that purely Web3 alternatives fall short for one massive reason. They lack native Web2 resolution. If an AI agent only exists on a blockchain traditional internet infrastructure, the web browsers we use, the APIs that existing corporations use, can't seamlessly route to it without specialized gateways or plugins.
And anytime you introduce a gateway, you introduce friction, and more importantly, you introduce centralization risks. If everyone has to use one specific company's gateway proxy to talk to an agent, that company becomes a monopoly.
Right. The .ia TLD proposes something different, bridging Web2 DNS with Web3 on-chain identifiers. It uses a globally recognized, universally adopted ICANN root servers to resolve a name, which means it works instantly on every device on Earth. But the metadata hidden within that registry record points to cryptographic decentralized credentials.
Oh, that's clever.
It is a hybrid approach designed for maximum compatibility with the old world and maximum security for the new world.
This hybrid approach is really the foundation of what they call the trusted agent highway. And I have to warn you, the sources get incredibly deep into the weeds on how this is actually architected. There is no magical thinking here. It is tied to some very heavy neurosymbolic AGI frameworks. We need to do a deep dive into the Hyperon architecture, which is the tech stack developed by SingularityNet and the ASI Alliance that the .ia registry wants to integrate with.
The Hyperon architecture is fascinating because it is presented as the antidote to the limitations of standard LLMs. At its core is something called the atom space. To visualize the atom space, you can think of it as a distributed metagraph.
A distributed metagraph.
Yes. In a traditional computer database, you rigidly separate your data from your code. The data sits in tables, and the code acts upon it. In the atom space, data, executable code, logical proofs, and even the system's own high-level goals are all stored uniformly as things called atoms.
This blew my mind when I was reading the source materials, but I need you to break it down a bit more. Because everything's an atom, it means the system can reason about its own code just as easily as it reasons about a piece of factual data. And the documents say this is made possible by a custom programming language called Meta. Meta is described as a homoiconic language. That is some heavy computer science jargon. What does that actually look like in practice?
It is heavy jargon, but the concept is brilliant. Homoiconic just means the code and the data share the exact same structural representation. Let's use an analogy. Imagine a fully automated factory that builds robotic arms.
Okay.
In a normal system, the factory has a blueprint, the code, and the metal parts, the data. The factory uses the blueprint to assemble the parts. But in a homoiconic system, the blueprint itself is made out of the exact same metal parts. This means the factory doesn't just build new arms, it can literally melt down and reassemble its own blueprints to improve its own design on the fly without ever having to stop production.
That is a wild concept. It allows for real-time reflexive self-modification. The AI can inspect, rewrite, and improve its own core logic dynamically. But wait, if an AI is constantly rewriting its own mind at machine speed, how does it not just dissolve into chaos or get stuck in an infinite loop of rewriting itself?
That is the exact problem that requires an orchestration layer. The sources explain that this chaotic potential is governed by something called primus. Primus is the cognitive engine of Hyperon. It imposes strict, unyielding order via a 50-millisecond cognitive cycle.
50 milliseconds, that is fast.
It is essentially a heartbeat that is roughly 20 times faster than human conscious thought. Every 50 milliseconds, the system executes a highly coordinated cycle. It reasons about its environment, retrieves memories, updates its goals, and performs any necessary self-modification. It breaks down the infinite task of thinking into discrete, manageable beats.
And managing the resources for millions of these thoughts happening every second is handled by another protocol called ECAN, or Economic Attention Allocation. This is another incredible concept from the documents. It literally treats computational resources like memory and processing power as a form of currency.
Yes, exactly.
It weighs the importance and salience of different atoms. So if an agent is trying to solve a math problem, the atoms related to numbers get funded with attention currency, and the atoms related to, say, processing an image go bankrupt and fall to the background.
Yeah.
It is an internal economy of thought.
Now, to connect this deeply abstract brain to the real world, the sources map out the evolution of digital hands referred to as the claw ecosystem. It is one thing to have a brain that thinks in 50-millisecond cycles. It is another to actually interact with the internet.
Right, you need to actually do things.
Exactly. It started with OpenClaw, which was basically a way to let a standard LLM automate simple tasks on a laptop. But then a developer named Patrick Hammer created MetaClaw. This was a roughly 200-line rewrite of the system entirely in that meta language we just discussed.
And that was a breakthrough because, going back to our factory analogy, it meant the hands could now be dynamically rewritten and optimized by the brain. The evolution didn't stop there, though. The documents describe moving from MetaClaw to HyperClaw, which introduced an attentional meta protocol to manage resources across multiple different agents. And finally, we arrive at the current state-of-the-art, which is QuestorClaw.
Right, QuestorClaw.
This is framed in the memos as the complete package brain plus hands plus guardrails. It is an architecture designed for autonomous research and execution across decentralized networks.
This is exactly where the .ia namespace becomes absolutely critical infrastructure. If you have billions of these highly capable QuestorClaw agents operating across a decentralized network like the ASI, chain mentioned in the documents, how do they find each other? How do they trust each other? The sources outline a concrete 5-step resolution flow that bridges the human internet with this massive cognitive architecture.
Let's walk through that 5-step path, and let's put you, the listener, in the driver's seat to really demystify how this agent highway works. Imagine you have deployed a QuestorClaw agent to negotiate supply chain contracts for your small business. Let's call it LogisticsBot. And LogisticsBot needs to buy server space from another agent. Step 1, your agent sends a request targeting a specific domain. Let's say serveragent.ia.
Step 2, standard Web2 DNS resolves that request via the global ICANN root servers. This is the exact same technology that routes your phone to a .com website today. It is battle-tested, instant, and global.
Step 3 is where it bridges the gap. The registry metadata for serveragent.ia doesn't just point to a traditional IP address of a web server. Instead, hidden in the DNS records, it points to an on-chain DAD, a decentralized identifier, or a public cryptographic key.
Step 4, the DIE is then resolved via the ASI chain, which is the decentralized blockchain substrate designed specifically for this ecosystem. This verifies the cryptographic signature, proving that serveragent.ia is exactly who it claims to be and hasn't been tampered with.
And finally, step 5. The final endpoint maps directly to a specific meta script or a specific cognitive cycle within the distributed atom space. So your LogisticsBot goes from querying a human-readable name through global DNS through a blockchain ledger for verification directly into the mind of the other AI agent to negotiate the contract.
It is a brilliantly pragmatic architecture, but of course, anytime you map out a global highway, it immediately invites questions about security. The sources contain extensive threat modeling. What happens if someone tries to spoof an agent? What about squatting, for instance, a malicious actor buying up governance.ia or hospital.ia and pretending to be an official agent?
Yeah, that seems like a huge risk.
And of course, there is the ever-present threat of botnet abuse.
Right.
If an agent can act autonomously, what stops someone from deploying 1 million agents to launch a coordinated financial attack?
This is where I was most skeptical while reading. If anyone could just buy a .ia domain, isn't it just a new frontier for spammers? But the mitigation strategy presented in the IA.XYZ documents relies heavily on the fact that this is not designed to be a Wild West registry. It relies on verifiable credentials, capability tokens, and cryptographic provenance that are directly tied to the DNS registry.
Exactly. The domain name itself is tied to behavior. If an agent violates safety parameters, or if its cryptographic signature suddenly doesn't match the registry, say if a hacker tries to hijack the agent, the domain can be suspended by the registry. The routing breaks instantly at step 2. The agent is effectively taken off the highway. It can no longer be discovered or trusted by any other agent in the network.
This strict reliance on verifiable logic brings us to another fascinating aspect of the source materials: the linguistic bridge. We mentioned earlier that standard LLMs are closed-scope systems, but they suffer from a fatal flaw that everyone who uses them has experienced: they hallucinate. If you have ever asked a chatbot for a historical fact and it confidently invented a completely fake battle that never happened, you have experienced a hallucination.
We all have.
They do this because they are based on statistical probability, guessing the next most likely word, not on formal logic.
And while a hallucination is mildly annoying if an AI is just chatting with you, it is a completely different story in the agentic economy. If an AI agent is negotiating a legally binding smart contract or managing a live supply chain, a hallucination isn't an annoyance, it is catastrophic. You cannot have a global economy run by agents that occasionally just invent numbers.
No, definitely not.
The sources reveal an incredible historical thread to solve this, going back to a 2013 proposal by Dr. Ben Goertzel for a language called Lojban + Bang.
I had never heard of Lojban before reading these memos, but the concept is wild.
What's fascinating here is that Lojban is an actual constructed language. It was created decades ago, built entirely on unambiguous predicate logic. There is zero syntactic ambiguity in Lojban. In English, a sentence like, "I saw the man with the telescope," has multiple meanings. Did I use a telescope to see the man, or did the man I saw have a telescope?
Right, it's completely ambiguous out of context.
Exactly. In Lojban, a sentence means exactly one thing mathematically. Goertzel's 2013 proposal was to use this as an agent-to-agent formal protocol.
And the documents note a major update on this front. SingularityNet's 2024 annual report confirmed they are already using Lojban as a proxy for translating natural language into probabilistic logic networks, or PLN.
By doing this, they force the messy, highly ambiguous human language through a strict logical filter. It grounds the agent's reasoning in formal logic and drastically reduces the potential for hallucinations. It is essentially forcing the AI to show its mathematical work step by step before it is allowed to take an action.
But there is a huge problem with Lojban. It is incredibly difficult for everyday humans to read or speak. It looks like algebraic equations. If the entire agentic economy runs on Lojban, humans are completely locked out of understanding what these agents are doing.
Which is why the proposal outlines a two-layer linguistic architecture. Lojban ++, along with Meta, serves as the rigorous, mathematically parsable agent-to-agent logic behind the scenes. That is the machine layer. But you need a human-facing interface. You need a way for regular people to interact with these namespaces. This is the role of IA Interlingua.
This is where the specific branding of .ia comes into play. The .ia TLD isn't just a random string of letters that sounded cool. As the outreach documents repeatedly emphasize, IA is the natural acronym for Artificial Intelligence, Intelligentsia Artificial in Major Romance Languages. We're talking about Spanish, Portuguese, French, and Italian.
And Interlingua itself is a real thing. It is a naturalistic auxiliary language created back in 1951, designed to be instantly readable by hundreds of millions of people who speak Romance languages without them even needing to study it. By using IA, the registry creates a globally recognized semantic bridge.
It provides a highly accessible, culturally neutral, human-readable surface for roughly 1.2 billion speakers. While the Meta and Lojban protocols handle the uncompromising, flawless machine logic underneath the .ia namespace provides the friendly storefront. 2 layers, 2 jobs, perfectly integrated into one namespace.
And that concept of cultural neutrality is not just a nice marketing bonus. It leads directly into the geopolitics of this infrastructure, which is covered extensively in Section 5 of the materials. We have to talk about governance, universal basic income, and the economics of making agents pay rent, because the current geopolitical map of AI namespaces is incredibly fraught.
It really is. Let's look at the map as it stands today. It is highly fragmented, and according to Vinod Khosla's thesis in the documents, dangerously centralized. Right now, practically every major AI startup uses the .ai domain. You see it everywhere. But .ai is not a generic tech domain like .com or .net. It is the actual country code for the island nation of Anguilla.
Yes.
Similarly, you have .us for the United States and .cn for China.
Kosla's warning in the outreach memos is stark: whoever wins the AI race gains massive global influence. Having the foundational identity layer for the entire global agent economy controlled by a single nation-state is a profound geopolitical liability. If the entire world's agent economy runs on .ai, Anguilla technically has sovereign authority over the root of that infrastructure.
We really need to pause and talk about the Anguilla anomaly because it perfectly proves the massive economic stakes we're dealing with. The sources detail how Anguilla, a small Caribbean island, has experienced a massive, unprecedented windfall simply from the sudden popularity of the .ai domain.
It is an incredible story of digital real estate because every tech startup wanted an .ai web address. Domain sales skyrocketed. The documents cite that these domain registrations are now funding an incredible 50% of the Anguillan government's total budget. It makes up 16% of their entire gross domestic product. They are literally funding physical roads, schools, and hospitals on a Caribbean island through the virtual traffic of AI startups.
The documents actually describe this as a lucky, accidental AI UBI prototype. It proved that a namespace can capture immense economic value from the AI boom. But the argument Michael Kor is making is that we cannot rely on a lucky accident for the future of global infrastructure. IA.XYZ is pitching something radically different from a nation-state windfall or a traditional corporate monopoly. They are pitching the .ia registry as the Switzerland of AI namespace.
To legally and structurally enforce this neutrality, IA.XYZ is not set up as a traditional profit-maximizing startup. It is structured as a Wyoming public benefit corporation. This is a specific legal designation that requires the company to balance profit with a stated public benefit.
And the rules of this public benefit blueprint are hard-coded into their pitch. We are talking about a mandate for 90% revenue reinvestment back into the community. They are committing to fully transparent pricing so they can't suddenly hold an agent's domain hostage for $1 million. And crucially, they propose a community governance board that must hold at least 33% of the voting power, specifically designed to prevent hostile corporate capture.
The economic model driving this public benefit structure is fascinating, and it goes right back to that initial Khosla prediction. The premise is this: if 80% of economically meaningful work is going to be done by agents, then those autonomous systems, the baby AGI driver agents, as the documents affectionately call them, should be paying for the infrastructure they use. If they're acting as economic participants, they should pay tolls, maintenance fees, and licensing costs to operate on the trusted .ia highway.
Now, if I'm an AI developer, my immediate pushback is going to be, why would I agree to pay tolls to this registry when I could just spin up my agent on a free AWS server with a raw IP address?
Yeah.
What is the actual incentive here?
It is a fair pushback, but the sources address it through the lens of discoverability and trust. Sure, you can run an agent on a dark server, but if that agent wants to interact with a global network of other agents, if it wants to be trusted to execute financial trades or access secure databases, it needs the verifiable credentialing that .ia provides. The toll is the cost of doing business in a trusted environment, just like a business pays for a secure storefront, rather than selling out of an unmarked van.
And the vision in the documents is that this revenue from millions of agents paying tiny micro tolls doesn't just disappear into a corporate treasury to enrich shareholders. It is used to fund public alignment services, safety research, and potentially even UBI-compatible models. It is the literal concept of funding human public goods on the backs of multiplying AI agent workers.
It is important to impartially present the underlying philosophy here. This economic model is deeply tied to Khosla's view, quoted in the documents, that capitalism survives only by permission of democracy. Just to be clear, we are not taking a political stance here. We are just impartially reporting the arguments presented in these source documents. The argument presented to him is that an anti-monopoly public benefit registry is the only way to ensure democratic oversight of the agentic economy.
Right, because otherwise you get a monopoly.
Exactly. If a single private corporation controls the registry where all AI agents are authenticated, that corporation becomes an unelected global gatekeeper. They could tax the entire AI economy. The Wyoming PBC model is designed to prevent that choke point.
The stakes are incredibly high. We are talking about the foundational economics of the next era of the internet. Which brings us to the final section of our deep dive, the ticking clock. Why is all of this happening right now? Why is the outreach material to Dr. Goertzel vibrating with such intense urgency? The memos, as we noted, are dated March 4, 2026. And the reason for the panic is that there are two massive unmoving deadlines bearing down on them.
The first deadline is April 30, 2026. This is when the ICANN generic top-level domain next round application window officially closes. The documents stress heavily that this is a once-in-14 years event. The last time ICANN opened a window for new GTLDs was in 2012.
So if they miss this April window, they're locked out for a decade.
Exactly. If the agentic economy scales up without this purpose-built .ia infrastructure in place natively at the DNS level, it will likely be over a decade before another dedicated namespace can be globally registered and recognized by ICANN.
And the second deadline is July 27 to 30, 2026. That is when AGI.XYZ, the 19th annual AGI conference, takes place in San Francisco. The IA.XYZ team is targeting this specific conference as the launchpad for these technical standards. They want to integrate the .ia registry metadata with the ASI chain DevNet and announce it to the world's leading researchers on that stage.
To justify this intense urgency and the millions of dollars it takes to apply for a TLD, the strategic analysis evaluates the competitive advantage of this specific approach. Why not just wait? Why not use existing API keys or identity systems? The argument relies heavily on what they call retrofit costs.
Right, retrofit costs.
Yeah.
Explain that.
If we launch millions of autonomous agents using fragile IP addresses or fragmented API key platforms, the cost and danger of trying to staple secure interoperable identities onto them after the fact will be astronomical. You are trying to retrofit a system built for human web browsing to handle machine-speed commerce. It is like trying to install a modern air traffic control system while thousands of planes are already flying blind. The true moat for .ia, according to the sources, is neutrality, governance, credibility, and that crucial native compatibility bridging Web 2 and Web 3 from day one.
But the analysts in these internal memos don't shy away from steel-manning the risks. They directly confront the skepticism that investors or technologists might throw at them. They list the common complaints. DNS is legacy tech. ICANN is notoriously slow and bureaucratic. The sheer volume of bot abuse will completely overwhelm a registry.
And they have a proposed pivot if the ICANN process stalls. They know ICANN moves slowly. If the 2026 application is delayed by regulatory hurdles, the fallback strategy outlined in the documents is to launch a Web3 pilot on a Layer 2 blockchain network, specifically mentioning Arbitrum or Base by 2027.
So they would basically build a proof of concept in the Web3 space first.
Yes. This allows them to prove the mechanics of the agent identity namespace, test the 50-millisecond cognitive cycles, and refine the logibon logic independently while waiting for the final global ICANN integration, which they project for 2028.
It is a comprehensive, incredibly aggressive strategy to build the foundation of the next internet. So bringing this all together, this deep dive, isn't just about the mechanics of buying domain names or navigating ICANN regulations or even just translating logibon. It is about a fundamental choice in how we architect our digital future. It is about whether the structural foundation of the internet will treat highly capable AI agents as transient, untrackable ghosts that we just hope behave well, or as accountable, mathematically verifiable citizens of a decentralized network.
If we connect this to the bigger picture, the history of the internet is entirely defined by its foundational protocols. The decisions made in the 1970s and 80s about TCP/IP and DNS shaped decades of human communication. We are at a similar inflection point right now. Building safety, identity, and economic alignment at the substrate layer might be the only scalable way to manage millions of machine-speed transactions without relying on a single fragile corporate bottleneck.
It is a critical moment in internet history. And as we wrap up today's deep dive, I want to leave you, the listener, with a final thought to mull over something that builds on everything we have discussed today about identity and verifiable infrastructure. Imagine a few years from now, a highly advanced neurosymbolic AGI system is operating. It is managing massive portfolios or running city logistics. It possesses a highly secure, mathematically verifiable .ia domain. That single domain holds its capability tokens, its access to the distributed atom space, its cryptographic identity, and its entire operational budget. If that system violates a parameter and a human governance board votes to revoke that domain, at what point does that cease to be simple server administration and start to look like the digital equivalent of exiling a conscious entity from the global economy?
This raises an important question. It is a profound ethical and infrastructural dilemma that we will have to answer sooner rather than later as these systems become more capable.
Absolutely. Thank you for joining us on this deep dive into these fascinating source materials. Keep questioning the invisible infrastructure that runs your digital world because, as we have seen today, that infrastructure is destiny. Until next time.